Okay, welcome everyone to our webinar, and I'll have a quick presentation about data warehouses, kind of their history, and a little bit about their future. So let's get started. So since we're targeting kind of financial services industry, I'll talk about data warehouses, how they evolved in financial services industry because it's complicated and it was very much applicable throughout the years. So we'll figure out kind of where they started, how the concept of data warehouse developed, and kind of what are the major components and how it works. And then I'm going to add certain considerations that more applicable to today's world where AI is taking over. Okay, so the history. Application development, or when we say system, right, computer system consisted historically of two elements. The front end, this is where the user enters the data into the system. It's a form, graphic user interface, right? So we call it graphic user interface. And right now, they try to make it all web-based, uh, this form where you can type some information. Web-based allows kind of disseminating this front end all over the world because it's a web page. Uh, but once we enter the data and click submit, the data goes into the database, right? And is stored in the database, right? So that's the idea. The next day, when we log in into our Gmail, right? We'll open Google, you click Gmail, you log in, and all your emails are retrieved back into your browser, right? So this is the basic architecture of an application, right? So the application has a front end and has a back end that we call the database. Okay? So that's kind of basic how the first software was created, the ability to store information and then come back next day, retrieve the information and kind of pick up where you left off. Uh, so during the interacting with the front end, what we do, we create transactions. Right? So every time you send the email, you created a transaction. But somebody sent you email, it's a transaction in your email box, and then you can open it, you can read it, you can delete it, you can copy it, you can store it in a folder. So all of this becomes a transaction, like an action on on a piece of data, right? So we call these systems where the users are doing something, initiating this data creation. We call them transactional systems, right? So single application or system, but users are clicking and users are creating transactions, right? So the term I want to use now is the transactional systems. That's where transactions originated, the new data originated. Okay, we good on that? We have the front end, back end. Front end is usually graphic user interface, back end is database. Any questions?
No.
Oh, no. Okay,
No.
so
So I
that's
have a question about ETL. I believe it's extract, transform,
wait,
load.
wait,
Okay.
wait. Yep,
Okay.
good question. We're coming there. There is no ETL here because it's a single transactional system. Okay, there is no ETL here. Now, in the organizations they have multiple business processes, different lines of businesses. So what happens in the bank, right? The banks are have a lot of products for us. They can have checking accounts, for example, right? They have auto loans, they have mortgages, they have student loans, they have products for the small business, they have credit cards, they have investments, for the wealth management, right? And many, many other products. Each product is the transactional system. So each product has this little front end attached, right? where people are initiating the transactions. Okay, right? So we started with one. Now we understand that one organization have multiple single use systems, those transactional systems. So far, so good,
Mhm.
right? So the complexities of business. Okay, so what happens next? Each system has their own marketing department, they have operations, but the company wants to know, hey, if Roman has a checking account, right? So Roman, let's say, has a checking account. Does he have an auto loan? Does he have a mortgage? Maybe he wants to take a student loan for his kids. Maybe he's got small business, right? Does he have like 25 credit cards? Does he have investments? Right? So if Roman is here, how we want to market other products to Roman? We want to know the whole relationship with Roman. So the company needs consolidation of this data. So before, each team would write a request and say, I'm in mortgages. Do you have Roman there? Do you have Roman's account number? Right? So, or for example, so the systems would, the team, each one has a team. Each each transactional system, they have a team that supports front end and back end. Here's they have a team that supports, front end and back end. There is an IT team also supporting IT team, IT team, IT team, IT team. You see how many teams we have in the organization? Separate teams, separate technologies. So when the business says, I have a question from the credit card, they would start building these processes, requesting data from the credit cards, sending data to small business. So it became the whole mess. All these building all these links was created very complicated uh, topology, very complicated relationships between teams. It was very hard to keep track who's responsible for what, who is sending data where. So it's really, really complicated to maintain. And the more systems you have, the more complicated data sending back and forth between teams. Okay. So and this is just amount of lines is incredible. I had work in my favorite company, Citigroup. So mm, we were supporting like 40 applications or something, right? So the manager, he had interns during summer. He had like high school kids. So what they did, they had like this big table, like I don't know, big space. They put systems as like planets, and then they connected all the systems with each other with little labels with the name of the job, name of the connection, what data is being sent. He just wanted to visualize this complexity, how data is flowing from where, and he kept it like in the middle of the floor. It was pretty interesting to see like how these databases connected with each other, right? He tried to visualize how complicated that was. So, like again, this is the mess. This is the idea. So they said, you know what? Instead of these multiple teams talking with each other using different technologies to communicate and send data, what if we put somebody in the middle, be like a mailman of data? Okay, so we'll call it data warehouse. So the idea is for all the systems send their data to one place instead of this system sending data to, here, 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 in different formats and different technologies at different time of day. 1, 2, 3, 4, 5, 6, 7. Let's just build one dump of data, one, which is consistent, right, into the data warehouse. Okay, instead of maintaining the 7 data dumps, making sure the data travels on time and complete all of that, let's just replace it with one data dump. And then let's all systems just give its data to this data warehouse. Okay, boom, like that. So this way, data warehouse will have the data from all the systems in one place. And it will be organized, we call it curated, normalized, uh, with a good business context. So we understand what's what. Right? At some point, I was on a project with Citigroup where they were building this data warehouse. And actually, they said, Roman, we're looking for a project manager. I'm like, so what am I managing? Well, you're managing us, and your job is to connect with all these teams and convince them that they have to send their data to us. Because and like, why? Well, they're sending 7 feeds, and we say, you have to send it to us because we will replace your 7 feeds. And the teams are smart and they say, well, if we just have to maintain one feed, you don't need 7 people. You probably will just need one person to maintain that feed. So there was a lot of resistance at that time from local teams, from these teams, right, to participate. These teams understand that simple uh, is good for the business, not good for the team. So these guys were resisting. Um, okay, so step 1, dump all the data into the data warehouse, right? And like I said, this data warehouse will grow very fast. So therefore, putting it on the cloud is probably the best decision, right? So allow for it to grow very quickly. Okay, so we all agree that this picture is better than the previous picture where it's total chaos, right? So 7 feeds is better than 49 feeds, right? All right, moving on. All right. Okay, so to disseminate the data, we also will will send the data now from the data warehouse to consumers, right? If somebody needs data in the organization, they don't have to come to individual systems. They say, hey, let's say mortgages want to know about checking accounts, right? So checking account sends the data here, and the mortgages say, okay, what's our view of checking accounts, right? So data warehouse can answer these questions. So we eliminate the need for mortgages to kind of talk to this team, talk to this team, talk to this team, talk to this team. No, they can only talk to one team, describe what they want, and that team will give them the data. So data warehouse team will control what goes where as well. Okay. So collecting data, step 1, disseminating data, step 2. Definitely, again, will simplify kind of relationship between the teams and understanding like what's going on with the data. Yulia, we good? You following?
Yes, I'm following. And I
Okay.
have a couple questions already.
I know, but so far so good. Like we understanding why we need it, okay?
Yes.
Okay, so one point, just the new part for this presentation is that we realize that we better, oh my God, what the hell just happened? Why? Okay. You guys still see the presentation? You see the
Yes.
present?
Yes.
Yes,
Yes,
yes.
okay, okay.
Yeah.
I don't know what happened. It's kind of like, it was weird. Okay, so we just want to keep this in the cloud, right? So this can grow. My cloud picture is a little bit. So the only point that this should be stored in the cloud right now. Okay, next. So moving on. So we're gonna disseminate data to everyone. Okay. All right. So now, how is it actually happening inside of the data warehouse? This is where Ina has a lot of expertise. Okay. So even though the in-house source systems or transactional systems also can be consumer systems, right? Data still flows from into the data warehouse and then out of the data warehouse, right? So the producer of the data and consumer of the data can be the same team. That's fine. But the data has to first get, flow in, and then they can see it or consume it. Okay. So the data warehouse consists of three parts. First part, we call it landing pad, staging area, landing zone. This is where those tables arrive. So we take the raw data, we're bringing in the data. The process is called ETL, extract, transform, load, right? So this is the original system databases. So there is a process that takes the data, like makes an extract, and lands it here in the raw format. So as it arrived, boom, it's from the system, they extract it, they land it. The reason is we're not transforming it much, so it's easy to kind of store it for backup and replace. So we can just put it. And then to store it in the data vault, really store it for the kind of for long storage in the data warehouse, we use another ETL that takes this denormalized data into the normalized database. Okay, so this is the storage history. They call it logical physical database, right? And nobody has allowed direct access. Nobody changes the data here. Okay, we are using ETL to make changes and keep the latest version. Now, these are the transactional systems in the house, inside, but we can have outside systems reference data, like market data, government data, some statistics, right? So they can also be fed into the data vault and stored, like latest prices or the closing prices for a day, opening prices for the day, right? So there can be some business rules that can be also stored, some calculations, for example, like the total for a day, your account balance at the end of the day. So that can be part of the business logic. Now, the way to extract data from the data warehouse is through the data marts. Data mart is like supermarket. You go and you have a coffee section and you go and you pick coffee. You want milk, you go to the milk section, you have a couple choices, you pick the milk, right? So pretty much it's like whatever you need, you can pick. So that's the idea for the data mart. So the idea there is that this data vault is huge. It's huge and it's normalized. Normalized, it means you have a lot of little tables with a lot of reference pointers. So running a real query on the data vault is taking a lot of memory and a lot of power. So it's better to create shells already, coffee, milk, some data context, prepare the tables using the ETL overnight, and then let the consumer systems, they say, oh, we want marketing data. Okay, you access this big table, but it's already prepared. So it will be fast. We want operational data. Okay, we can get it. You want financial data. Okay, it's already prepared for you, right? We want something like monthly report. Okay, it's also available, right? So preparing these tables, again, it takes more space to create these tables, but they're making these ETLs much faster, okay? To extract data from the data warehouse. Okay, Yulia, here's the time for questions.
What is different between data lake and data warehouse?
Okay, very good questions. So the data warehouse has these in-house source systems. They sending their data at the end of the day, Okay, the data lake. So the house is kind of stable. Lake. Um, so the concept of lake is that you have many rivers, like and river doesn't stop, right? So you have rivers constantly adding data. So in a data lake, you have these outside system reference data, right? It can be real time, and sometimes you have transactional systems also sending data real time. So when you add real time to this picture, you get a data lake. Okay.
Thank you. Yes, I got it. Thank you.
Okay. What's another question?
Oh, you already answered about ETL.
Okay. Excellent. Okay, yeah, I just wanted to make sure I'm going to answer all the questions because we are running, towards the end of the presentation. Okay, so that's the concept of this data warehouse. Really, this is where we want to stop. And so what's why is it important for AI implementation? Because out of this data warehouse, this is where we can kind of give the requirements and we can create these tables that we can feed to AI for doing machine learning. It's much easier to prepare this data if we have access to the data warehouse, because there we have enormous amount of information. We're not putting any stress on the transactional systems, right? So we want to have our own data mart that we can use to feed AI, right? So it learns, and then again we can put this AI here and then work with the source systems. So without this data warehouse, it will be very, very hard to prepare training data for our AI. And also like to have this another huge data mart for AI without being this data warehouse on the cloud will be almost impossible. So these things coming together allow us to take the next leap in information technology kind of evolution.
Thanks for that, Roman.
Yeah, you